Welcome to the Deep Dive, the place where we take hyper-focused source material, the kind of notes that usually only the author ever sees, and we turn them into powerful, transferable knowledge for you.
And today we have one of the most delightfully niche sources we've come across in a while. Our deep dive is built around a single excerpt from a website.
Right.
It's called keynming.org, Notes on Gardening, and this is part 778.
778, wow.
Yeah, and the author is someone who refers to themselves, I think quite brilliantly, as an old software plumber.
I love that. I love the paradox of it already. So our mission today is to zoom right in on this specific gardening experiment. We want to extract two things. First, the guaranteed practical secrets to germination success. And second, the really profound transferable insights on methodical curiosity that the software plumber seems to apply to, well, everything they touch.
Exactly. This specific note, this part 778, it details the findings after an experiment involving sprouting a popular mixed spice blend.
A spice blend. Not just regular seeds from a packet.
Right. It's known as Panch Phoron. And the core question the author was looking at was simple, but, really powerful. When you put 5 different competitive species of seed into the same pot, which one dominates?
Yeah.
And more importantly, what does the winner's victory tell us about its biological resilience, its viability?
Okay, so we need to clarify the environment here. This isn't just planting a neat row of carrots.
No, not at all.
Panch Phoron, that translates to 5 spice, right? It's a huge staple in Bengali and Eastern Indian cooking. So this is a true test of competitive viability.
That's crucial context.
Yeah.
Absolutely. Panch Phoron is typically a mix of 5 whole seeds. They're often used raw or tempered in oil. And these 5 competitors are usually fenugreek, nigella, cumin, fennel, and sword. Most importantly for this experiment, mustard.
So you're throwing all 5 of them in together.
You are. You blend those 5 together and you plant them. And what you're really doing is observing a competitive germination hierarchy in miniature, a little plant battle royale.
So you've got 5 different species, all vying for the same soil, the same light, the same water. I mean, you'd expect a pretty mixed result, right? A few of each, maybe?
You would.
Yeah.
But that's not what our software plumber found. So let's unpack the immediate visual success story.
Yeah.
Because the winner was emphatic.
Emphatic how?
It wasn't even a contest. The black mustard, that's Brassica nigra, it didn't just win, it staged a full-scale takeover.
The takeover?
Yeah. The author noted that the pot was, and I'm quoting, largely carpeted in its seedlings. So that's the first practical nugget for anyone listening. If you need a reliable success story, it seems like mustard is your baseline.
And the beauty of this methodical approach is that the author didn't just stop at noting a bunch of things grew.
Of course not.
They immediately started identifying the specific characteristics of the winners and the runners-up. So how do you spot that victorious mustard right away?
Well, the primary visual ID is its leaves. The seedling leaves of mustard are described as broad and distinctly heart-shaped.
What-shaped?
Okay. They provide a recognizable, standardized input. And if you think about it from a programmer's perspective, that's essential for confirming the output. They know exactly which variable is generating the dominant result.
So what about the second place finisher? What about the fenugreek?
So fenugreek, its scientific name is Trigonella funumgracum. That was the next distinguishable species.
And how did he spot that one?
Its seedlings are recognizable by their oval oblong leaves. So you have this clear visual distinction.
Right, the broad, heart-shaped leaf of the mustard dominating the whole pot, and then this more specific oval shape of the fenugreek coming in second.
Exactly.
The documentation is so careful here, though. I mean, the author makes a point of saying they can only identify the remaining smaller plants, the cumin, nigella, or fennel, with greater certainty once their true leaves begin to emerge.
And that's the scientist speaking. It's demanding patience and precision. They are setting up checkpoints, almost like debugging code. You identify the major successes now, but you withhold judgment on the more complex variables until you have more concrete data points. In this case, that's the true leaves. This note is less about gardening and more about the meticulous process of isolating variables.
This level of detail in just a simple gardening note, it really underscores the core insight of this entire source, doesn't it? The remarkable, almost unbelievable viability of the mustard seed.
That's the central discovery, and it's one that translates across disciplines. The experiment is just. It's strong proof of the resilience of both black and brown mustard seeds. But we really need to spend some time on the data supporting this.
Because this isn't just a one-time happy accident.
Not at all. This is presented as a repeatable finding.
So what's the evidence? What's the proof that this is a truly repeatable finding, a known behavior of the mustard seed?
The source author explicitly points out that they successfully germinated mustard seeds in previous trials. And these are seeds that were labeled as long expired or dormant.
Wait, long expired?
Long expired. Think about what that means for a second. We're talking about seeds that, by all common knowledge, by the expiry dates on the packet, they should be inert, biologically dead.
And yet
They sprang back to life.
that is genuinely surprising. It suggests a survival mechanism far, far beyond what we expect from a dry pantry staple. But wait a minute, if mustard dominates so completely, and even the old seeds work, doesn't that inherently make the experiment a failure for the other 4 components of the Panch Phoron?
That's a great question.
Is the author just ignoring the species that didn't do well?
Not at all. In fact, for someone applying the principles of rigorous experimentation, failure is just as valuable as success. It's just another form of data.
Okay, so how is that failure useful?
The dominance of mustard means that its parameters for success are extremely wide and reliable. The fenugreek is reliable, sure, but it clearly requires a slightly different or maybe more precise set of conditions, which makes it a higher variable.
So the failure of the other seeds to compete doesn't invalidate the research.
Well,
it simply establishes mustard as the perfect low variability control group for all future tests.
exactly. When you are running iterative experiments, whether that's in software or in horticulture, you need a known, reliable input that will yield a predictable output. The fact that mustard seeds, even seeds from a packet from 2015, function perfectly, that makes them the known good.
Or the staple.
They're the staple for any future germination experiment the author conducts.
And that ties directly into the practical application for you, for anyone listening who wants to start growing something. If you want guaranteed, quick results, why should you start with mustard?
The author basically provides a checklist that is universally appealing. First, mustard seeds are readily available. You can find them in any grocery store.
Sure.
Second, they are highly affordable. You are not investing in expensive specialty seeds. And most importantly, they yield quick, reliable results.
Right.
So if you're just dipping your toe into gardening, you start with the seed that has the best historical data for success. It builds confidence. It builds momentum. It's the equivalent of running a simple, guaranteed Hello World program before you try to tackle more complex code.
I love that parallel. It's perfect. The resilience of the seed mirrors the persistence you need to learn any new skill. And based on this proven exceptional track record, mustard has officially joined 2 other species as staples for the author's future experiments and evaluations.
Basil and celosia.
Right. So those 3, mustard, basil, and celosia, they are the bedrock.
They're the author's standard library of reliable biological variables. So if the author is testing a new soil mix or a new container or a new light setup, they use these known good seeds to establish a benchmark. It's methodical, standardized testing applied to dirt and water.
This systematic approach, it leads us to the bigger picture because these gardening notes are not happening in isolation.
No, not at all.
This is just one of many, many documented projects by this self-described old software plumber.
And the source context here is everything. We're not looking at a one-off hobby. We're looking at a system of documented curiosity. The author's background is in managing complex software systems, the plumbing of the digital world.
Right.
And they apply that exact same discipline, that same rigor, to every area of their life.
The documentation habit is it's astonishing. Let's look at how they apply this programming mindset to other completely unrelated fields. It's not just that they have many hobbies, it's how they document them.
Exactly. I mean, consider the sheer breadth of documentation. They maintain deep dives into challenging programming languages like Haskell, Python, Go, Rust, and Elixir Erlang.
Okay, that makes sense with this software background.
Sure. But then they catalog their domestic and health pursuits with the exact same dedication. We have these long-running series like Notes on Dieting, Part 113.
Part 113.
And specific logs like Miskig Fish's Spawn Logs.
Okay, let's break down that link. How does tracking a fish spawn or a diet log parallel writing code or testing seed viability?
It's all about version control and rigorous input-output tracking.
I see.
Take the dieting notes.
Yeah.
To get to Part 113 means they have continuously run an experiment on their own body for years, adjusting variables, calories, macronutrients, timing, and logging the outputs.
The outputs being weight, energy levels?
Weight, energy, blood markers, you name it. That is essentially continuous integration and delivery applied to human health. In programming, you track every commit and every bug fix. In their life, they track every adjustment and every result.
That makes the gardening note about the heart-shaped leaves and the Latin names make perfect sense now.
Right.
It's not enough to write seed grew. You need precise identification tags. It's like standardized documentation in a huge open source project.
Precisely. In the complex world of software, you have to standardize inputs to get reliable outputs. If you use the common name mustard, you're introducing ambiguity. But if you log it as Brassica nigra, you have minimized that ambiguity. They are applying the principle of unambiguous documentation, which is a critical skill in programming to horticulture. They're ensuring that 5 years from now, when they look back at Notes on Gardening, Part 778, the data is still clean and usable.
So the core value here, then, isn't just that mustard seeds are great. It's that the author transforms every subject into a solvable, trackable, and optimized experiment.
Yes.
Whether it's attempting the Pearl Weekly challenges, optimizing their fish tank conditions, or testing seed viability, they are always collecting, logging, and refining.
They're maximizing their learning velocity. They don't just learn by doing, they learn by documenting the doing, which allows them to refer back and see patterns over vast periods of time. The success of the old dormant mustard seeds isn't a miracle to them.
No.
It's a critical data point confirming the stability of a biological variable over time.
It's the ultimate transferable skill set. Take an intellectual curiosity and structure it like a repeatable, data-driven system. That's the real insight the software plumber offers us.
And it makes their documentation so trustworthy. When they say the mustard dominated, we trust that assessment because we know the rigor and the systematic approach they apply to every other area of their life.
So let's bring this all back to the practical takeaways for you listening. If you are starting a garden or maybe just running a viability test for fun, the data from this deep dive is crystal clear. Black or brown mustard seeds are your fastest, cheapest, and most reliable option. You are almost guaranteed success, and it proves that viability is far more enduring than the expiration date on the packet would have you believe.
And maybe let's end with a final provocative thought, one that builds on this idea of extreme seed resilience.
Okay.
If this old software plumber can repeatedly resurrect seeds that were described as long expired and dormant, which means the plant's essential DNA survived years of, being dried out and stored, what does that teach us about the long-term survival mechanisms nature employs for common pantry staples?
That raises a fascinating question about sustainability and food preparedness, doesn't it? If the seed's biological mechanisms are that robust, how might leveraging that extreme viability, that natural ability to go dormant and then spring back, how might that impact the way we design future food storage facilities?
Or even global seed bank strategies.
Exactly. These small, unassuming spice seeds hold immense biological promise far beyond our kitchen spice racks.
It's proof that sometimes the most profound insights are hidden in the most mundane, well-documented places.
Just like our methodical software plumber, we encourage you to apply that spirit of rigorous, documented experimentation to whatever area of curiosity you decide to dive into next. Thanks for joining us for this deep dive.